Dilations produce figures that are similar. Similar figures use this curly, almost like a hyphen. It's like the very top of the congruent symbol to describe to show that two figures are similar. Similar figures are two figures with congruent angles and corresponding sides in proportion. When we name similar triangles, corresponding angles and sides need to be in order, just like they were when they were congruent triangles. So for example, over here on the right, I have triangle ABC. And if I'm looking for corresponding angles, I'm going to look for those corresponding vertices. Triangle ABC is similar to triangle. A corresponds with D. Vertex B and angle B corresponds with angle E. And C corresponds with F. Now, these are oriented in the same direction, and the angles are marked. But another thing that we can look at is the corresponding sides, and those corresponding sides are also going to help us determine the scale factor. So when I look for corresponding sides, the first thing that I'm going to do is I'm going to look for the shortest side of both figures. So AB corresponds with DE. I also can determine that BC corresponds with EF and AC corresponds with DF because I can match the shorter two sides, the medium sides, and the larger sides of each figure. Now, when we're talking about scale factor, we've talked about how scale factor is the letter K, and that is something, a side of an image over the side in the pre-image. Now, you do have to be careful about which way the question is asked when determining scale factor. For this top bullet, it says, what is the scale factor of ABC to DEF? Whenever you see the word to, that means that the second one is my image, because I would be going from this to that. And I can already see that this is an enlargement. My scale factor should be greater than 1. So what I'm going to do is I'm going to match up any two corresponding sides to determine the scale factor. And I'm going to make sure that I put triangle DEF or the image on top when I write these ratios. So DEF one side would be 12, its corresponding side is 8. Now what I can do is I can simplify that ratio. These are both divisible by 4. So if I simplify this ratio, I get 3 to 2. And I'm just going to verify for you that that's true no matter which two pairs of corresponding sides you pick. So now I'm going to say 15 is my green side in my image over 10 in my pre-image. And both of those are divisible by 5. But regardless, that gives me a scale factor of 3 to 2. And I can also, instead of having numbers in, I can also just write these as segments. So DF over AC would also be a way that I could acknowledge the scale factor. Now going the opposite way, if I'm going from DEF to ABC, now ABC is going to be my image, and it's going to be a reduction going from one to the other. So I'm going to expect that my scale factor is less than 1. Again, I'm going to match up two pairs of corresponding sides, or at least one pair of corresponding sides. So here I'm going to say that one would be, let's say AB is on top, AB over DE, because that is a side of my image over a side of my pre-image. And the ratio of AB to DE is 8 to 12, which again, in simplest form, would be this time 2 to 3. And I'm just verifying in my own brain when I finish that I've made sure that my image is on top, and that if it is a reduction, my scale factor should be less than 1. And if it's an enlargement, my scale factor should be greater than 1.